So it's kind of fitting this is the experiments track, because it's worth noting that the whole point of an experiment is to try something that you aren't really sure is going to work. Otherwise, it wouldn't be an experiment. When we made the plans to submit this presentation, we were in the midst of the project, and what we're trying to do is we're trying also to deploy Cloud Foundry on top of Kube, but using a different mechanism than Fissile. We were trying to do old school Bosh with a CPI. And when we first envisioned it, submitted the talk, it meant our subtitle is A Tale of Two Brains. Think of it kind of as a horror story, if you like. That's going to be kind of a theme that goes throughout this talk. But this is how we kind of thought we'd be coming in here. This was going to be a victory lap. We were going to come in here. I was going to drop. I was maybe going to flex a little bit and brag about this awesomely successful project that we'd had. And then about a month ago, we ended up more like this. We kind of realized, wow, we kind of need to rewrite this presentation a little bit. Maybe more than a little bit. But things are not always as dark as they seem, because the whole point of an experiment, again, is, to figure out what doesn't work so that you can focus on what does work. And so, we feel that there was some fruit to our labor, so to speak. And so we're going to describe a project that, at least on its face, you might think, wow, this really sucked, it didn't succeed. But I don't think that's actually true. We simply explored some avenues that we said, these maybe weren't the right things. Or maybe we said, the effort it would take to invest in this to get further along wasn't worth it yet, or it would take more effort. So that's what I kind of want you to take away from this whole presentation. So, this guy, he's no longer even playing football. That's not really where we are. I don't have an appropriate slide for something more speculative and a little more ambiguous, but that's where I think we land up. So, starting off, Bosh supports, yada yada, we all know this. Bosh supports lots of IaaS layers. I think I got them all up there, and if I didn't, I apologize. So the question one might ask, that apparently a lot of people other than us are also asking is, so why not Kube, right? And that's what we were asking inside IBM, was why not Kube? And it wasn't just a why not thing. We like a lot of people here, we have our Cloud Foundry as a service, but we also have a container service. So we're pretty heavily invested in sort of both pieces of the puzzle. And so we want to see, well, could we take the scope of Kube and expand it to be more of a generalized IaaS layer, and could we actually then run Cloud Foundry on top of it? And so we started down this road. Actually, two sort of POCs existed for a CPI for Kubernetes to allow Bosh to deploy Bosh releases on top of Kubernetes. One written by Jan that I think he presented on back in Santa Clara in June, and then one by Matt Sykes, a fellow IBMer. Some of you may remember, used to be very active in the community, that we had. So we had a base on which to build. We weren't starting wholly from scratch, and obviously, we all knew going in, hey, Kube has some stuff that it does really well, some of the same stuff that Cloud Foundry does really well, and we were like, hey, we want to be able to take advantage of that because it's stuff that maybe a traditional IaaS layer doesn't really offer. So you're asking, why not? Because the mountain was there. Well, why were you trying to do this? We thought if we could actually succeed at this, there's some real value to this. Okay, so we had some goals. We were starting off, obviously, we wanted to get Cloud Foundry on top of Kube. And in this case, the Kube that we're using was, and you'll see this if you actually pull at the end of this, I think I've got a URL for our CPI repo, which is public. We've got some hard-coded things like annotations and stuff. So we're focused on our Kube implementation, the IBM Cloud Container Service, but it's generalized enough that we wanted to eventually get to an approach where you could pull that stuff out, externalize it into configuration, and use anybody's Kube. And again, it was, could we use Kube as a sort of a more generalized IaaS layer? And having done that, could we take advantage of some of the Kube secret sauce and maybe make Cloud Foundry more awesome? But we also had some restrictions. So, Vlad just described a really interesting approach, kind of diverging from the traditional Bosh deploy. We were fenced in. We had to use Bosh for a variety of reasons. One of the primary ones, we're pretty heavily invested in it in terms of our operations. We weren't going to tell all of our operators, hey, guess what? Your whole tool chain, screw it. We're going to do something different. We wanted to provide a sort of an on-ramp rather than climbing a steep cliff. And another one was the deployment model we were looking at is we wanted to have sort of a master-slave sort of topology where we had one Bosh director deploying multiple instances of Cloud Foundry. This was related to our business model and our use case, so it wasn't just a director, a Cloud Foundry, a director out, a Cloud Foundry. And just bring these up so you may reach certain points, you almost certainly will, because there are a lot of smart people in this room, where you look at some of the stuff we put up here and be like, dude, that's totally solvable. And you're right. But every problem is only solvable within certain parameters, so I want to get our parameters out there. And while I'm on that topic, I'll also point out there are a lot of things we're going to bring up where we hit a wall, but it's kind of you'll say that wall is kind of a soft wall, or there's a door in the middle, or maybe a loose brick that if you pull it, the wall comes tumbling down. Again, you're probably right. And I'll revisit this theme at the end of the presentation. So that's what we were kind of looking at. We had a Bosh director, multiple kube clusters, okay, with each one with a CF instance. That's what we wanted to realize. All right, so Bosh has a certain view of the world. Bosh is not wholly agnostic, obviously. And there are a couple key assumptions it makes. There are probably more, but I'm just going to go through a couple. One, if you have a Bosh job, the IP address, you can't change it under the covers and have things work happily. Bosh says, no, leave that alone. Once you got an IP address, I want it to keep that IP address. And by the way, this is the way Bosh works, is once you spin up a VM from the stem cell, I'm going to put some stuff on it, right? Now, that seems kind of obvious, but it matters in this story. Why? Because Kube also has some expectations, and they're slightly different than what Bosh expects. So guess what? Kube states, well, actually, so Docker, which Kube originally was sort of built around, allows you to say, I'm going to have a Docker machine. It's always going to have the same IP address. But Kube explicitly says the other things. Kube says, don't use the IP address. You may not guarantee that the IP address will be the same for any given container over its lifetime. I'm going to recreate it in the container. I might recreate this container, might recreate the whole pod, and the IP address might change. Yeah, so what? Use names, don't use IP addresses. Other thing, it's a container technology, right? We all remember Jules' talk, state doesn't go inside containers. State is bad. Well, these two don't quite match up. Bosh says, no, stable IP addresses. Kube says, no stable IP addresses. Bosh says, I'm going to put stuff on a job after I spin it up. Kube says, no. Once I spin it up, that's the shape of the software. So again, this is how we're navigating, and this is why I bring up that graphic at the beginning of the slide. It's really a tale of two brains. We got two brains, each one of which perceives the world in a different way, and we're trying to navigate the middle ground, or maybe we're trying to build a bridge across that middle ground. So most of the complexity in the problem really derives from this essentially a big mapping problem, or series of mapping problems. How do we avoid the seemingly obvious split brain dual control issues? In some cases, we couldn't avoid them, is the honest truth. Maybe they're avoidable, given more time and resources. Maybe. Also, what does a VM mean? So Bosh only knows about VMs. Everything in the world to Bosh is a VM. Obviously, Kube deals with containers. Those are different things. And Kube actually has, if you've ever gotten hands-on with Kube, it is different ways of representing. It has pods, it has stateful sets, it has replica sets, which are encapsulated by a deployment. So there's not a nice, neat one-to-one cardinality between the two worlds. So what does it mean to deploy a VM on Kube? And also different things, like how do you manage storage? For example, you can't just mount, in the Kube world, you don't just mount a disk onto a pod. It has to be there at the time you spin up the pod. Which is a little bit wonky when you dig into the Bosh flow. And how to manage other resources, address namespace mappings. These are just, all these areas are where we get into complexity. But really, that first bullet about the split brain, they're all variations on a theme, at least from our experience. So, the CPI. Well, on its surface, our CPI it's just like any other CPI. I mean, it has to be, right? It's a CLI executable, runs on the director, takes in JSON requests. That's how it works. That's how all CPIs work, so it's nothing magic there. We chose, because we met Jan and didn't like him, we chose Matt Sykes' piece. No, we chose to build him because, frankly, it was written in Go. We had skills in-house in Go, and Matt was like 3 aisles over, so if it broke, we could yell at him and say, Matt, come help us. So that's why we went with this one. It was no more complex than that. But our CPI is also different in some fairly fundamental ways. It's got to deal with some specific considerations that you don't have to deal with. Again, the mapping. What's a VM? Is it a pod? That's kind of where we started off with, but if you just make things a pod, well, you're not getting all the power of Kubernetes. So we always had our eyes on a further prize. Can we make it a replica set? Can we make it a stateful set? Also, again, as I brought up earlier, there's some kube-specific behaviors. You can't just attach a disk to a running pod. You actually have to recreate the pod with the disk as part of the manifest. And not all the methods are available or even logical. So, for instance, we were starting with kube, I want to say 156. I think that's about right. So volume snapshots weren't even available. That wasn't even in that release of kube. I think those came in 1.7 maybe. Don't remember. Doesn't matter. At the time we started, not there. And also, what does it mean to do a restart? Well, there is no real restart function available externally. The kubelet can restart your pods for you. If it sees it's crashing, I'll restart it, but it's not like a behavior that's obviously exposed. The idea is, you could recreate the thing. So what does it mean to do like a Bosh restart? We had to sort of sit down and think through the semantics of these actions. And some of the commands, even though they're not really things that you implement in the CPI, because not everything you do, I don't know if any of you ever dug into the guts of Bosh, the Bosh CLI and the CPI, but you have Bosh and then you have a verb. Not all the verbs are actually going through the CPI, like Bosh SSH, for example. That's not a CPI thing, that's just a Bosh thing. It's a little wonky how that works in the kube world. And you have to figure out, what does that mean? Are we going to shell out and run a kube control exec? Again, solvable problems, but at some point the duct tape and baling wire begins to gather and you get a little bit entangled in it. Okay, so our CPI, again, it's just like every other CPI. It's got a standard set of CPI methods that we implemented. If you've ever dug in, if you look at the CPI API, these are all there. So we got most of them. There's some we don't have yet. But these are the major ones. And these were enough, honestly, for in our initial deployments, we were able to get far enough that we were able to say, hey, this is viable. This is enough there for us to actually do a CF deploy. We had a couple of initial deploys where we could push an app and it was working. But at some point, Monika's going to step here and tell you about what happened after those initial deployments. So we hit some bumps. So one of my favorite quotes from Jules, and I've got a lot of favorite Jules quotes. Friends don't let friends push CF push MongoDB. And the idea is that there's just some things where they just, you don't.
Amen.
Yeah. It's also one of Dr. Nick's favorite quotes, apparently. Specifically he's talking about, you don't put stateful workloads in containers. And obviously we're talking about trying to put a lot of, from kube's perspective, stateful workloads in containers. We're doing, but what really is realize at some point, is it a square peg into a round hole? Are we just trying to make two worlds match that aren't meant to match? That's the question that I still have. So I'm going to let Monika pick up and tell you about some of these, round holes and square pegs for a little bit.
Yeah, I can do. So let's talk about the issues in more detail. So as Sandy explained, we have issues for the workflow state, IP address stability, and now for the containerization. And I'm going to talk about this in detail now. Coming to the next one. So coming now to the first issue about the workflow state. As Sandy already explained, Kubernetes expects that the workflows are stateless. And this means that when you have to recreate or restart some pods or so, then no data should be lost. This is the philosophy of Kubernetes. Bosh is acting a different way. So when you use Bosh, then the workflow is not really stateless. It has a state. For example, when you deploy via Bosh, and then you have to do some post-creation, installation, and configuration steps for your release packages. And the problem is that the Kubernetes does not know anything about this state, which is really configured in Bosh itself. And this has now the trouble, and we already picked this trouble when we did the proof of concept. So when the Kubernetes master node is thinking that something is not running well, then the Kubernetes master is going to decide by itself that something has to be reloaded. And it could be the case that some containers are deleted and going away to some other worker nodes on the Kubernetes cluster. And unfortunately, it could be that the Bosh director itself is some of this pod and it's going away. And we were really surprised to see that the Bosh director was not there, because the Kubernetes master node decided to delete this pod where the Bosh director is on, and it was gone. So it was really surprising for us. We have to search for the Bosh director. And Andrew, do you remember?
If you do this, make sure your Bosh director database is not there.
Yeah, so it was a pretty hard time to get this reconfigured, but it was only a proof of concept. So when you imagine that you have a production environment, then you are really in trouble. So coming now to the second issue, it's about the IP address stability, what Sandy already explained. So Bosh requires really that the IP address will be the same when you do the job deployment. And this really includes when you do a restart, recreate of the VM, when you're using the Bosh command, that you still have the same IP address. Kubernetes has another philosophy. So Kubernetes expect that you don't target anything via IP address. So Kubernetes is really using the high level identifier, so host names, etc. And of course, we have just overcome these problems, and we have to manipulate a little bit our worker nodes. So we have to compile the so-called Calico wrapper binary, and we have to configure the worker node so that the Calico wrapper binary is used. And in addition, we had to create a specific IP pool on this worker node so that it's clear for Kubernetes that a specific range of IP addresses belongs to Bosh and not to Kubernetes. So we have to, just configured this in a specific way. We have static IP addresses on the worker node, and which is really independent from the Kubernetes assigned IP addresses. And we found no really way to overcome this with replica sets or stateful sets, which is available in Kubernetes. And then, of course, we have to listen to what Cloud Foundry is requiring with respect to Diego cells. And as you know, Diego cells required a specific quantity of a set of local disks. And yes, we could overcome this just putting all the one cell to one worker node, and this can be done with the anti-collocation pattern, which is available in Kubernetes. But then, of course, the question comes up: why are we using Kubernetes then? Yeah. Okay, now the third issue, I think I will pass over to Sandy again.
Yeah. So nested containerization. They're not really truly nested, but effectively that's what it is, because you've got a Kubernetes worker, that's a virtual machine, and then you've got your Diego cell that's running as a pod or a container, maybe it's replica set. I'll just say pod generically, and then you've got garden containers for your apps running on top of that. So you've got nested containers. Effectively, needless to say, this isn't how most people envision people using containers. So it's the edgiest of edge cases. So initially, and I'm bringing up the worker customization because we were working with our service, our Kubernetes service, and they had a worker node image. When they provision new worker nodes for new customers, here's your worker node, here's your cluster, yada yada. And we kept having to go back to them and say, oh, we need some changes for our case. So one was we had to get swap accounting enabled in the kernel. It's not a big deal. It's just a boot parameter, and you pay a slight performance cost, but for 99% of people out there, they probably wouldn't notice it, right? So, no big deal. Now, the funny thing happened is that they changed. They were originally using, I think AOFS is their Docker storage driver. And then one day they said, we're going to change to overlay. And we woke up one morning, we were like, we can't push apps anymore. What's going on here? Nested containerization was broken. We went to Jules, and he said, you probably want to ask them what they're doing for their storage driver. We went and asked them and said, yeah, we switched over. Like, yikes, you broke us. And this is a theme that I think is also worth noting. If you were running a Kubernetes cluster or a Kubernetes service for the rest of the world, they did absolutely the right thing. overlay is what you probably should be using. All the docs for Docker and Kubernetes say that's what you should be using if you can. So they made the right decision, which I only bring up to point out, again, we are kind of on the edge. They're making the right choice in an abstract, and this is something where, when you're asking somebody to do something that is right for the 1% and wrong for the 99%, you got to sometimes ask, why am I doing this? Okay, but so we figured out, there's a way forward. We'll make this work, right? We'll figure out, you guys will give us a custom worker image, and we'll get one that's specifically tailored. We'll have the right combination of storage drivers that allow nesting containerization to work. Obviously, it can be made to work. The SUSE guys have it working. I think they're using Groot in Garden, and so obviously there are combinations that in today's world can be made to work. But there's a cost to this. So we're not just running this as an experiment. We're also looking at, we want to use this as a way of deploying Cloud Foundry for production deployments, for actual paying customers. So we've got to live with the solution. Remember, I brought up at the beginning, this isn't so much as a failed experiment, such as an experiment where we're investigating a path within certain parameters. It's possible someone else might do this and say, no, I'm going to punch through that wall. That's worth it for you. For us, we were like, if we're going to have to live with this, a whole separate pipeline where we're having to fork our worker image and we're deviating from what our standard production service is, OpEx usually outweighs CapEx, usually by multiple orders of magnitude, and we're like, the OpEx is looking ugly here. So, it gets even edgier because guess what? Not only could the Kube guys change what's going on, Garden can change too. So there's our cell down there. It's running overlay FS, right? The world is happy. And Garden currently uses AOFS. I think the Groot FS functionality is coming, and there's our Garden container, right? World is happy, right? We got our nested containerization working. And we know from experience there are some configurations to which this can work, right? All right. But guess what? Garden's going to move to overlay for their file system. That's a little funky. Because guess what? Overlay doesn't support itself as a backing file system. It only supports ext4 and XFS. There might be something else that supports, I don't remember, but I know for a fact overlay is not on the list of supported backing file systems. So guess what happens when you do that? Garden will actually check, hey, am I running nested? And you get that. That wasn't what we wanted, needless to say. So, hilarity ensues. So at this point, we sort of said, this is a lot of issues mounting up. Again, I know I'm beating this horse completely dead. It's just shredded on the floor. But individually, these problems are solvable. I don't think any of these problems are unsolvable technically. It's when you take them all together in the parameters that we had, was it worth trying to push forward? And that's why we sort of made a decision, let's push the pause button. And that's why I want to end here to some extent with an open door. So I don't view the door on this as closed. I think there's work here that's worth potentially pursuing. I just think there's some maturity that needs to happen. And maturity may be the wrong word. If one were want to pursue a Kube CPI and actually use Bosh to deploy things productively onto Kube, I think some things would need to happen. And a couple ideas. Well, first of all, smart people should pick up our CPI and see if they can improve it. Because I'm not going to try to pretend it's perfect. It's not. I'd love to see what somebody could pick it up and do with it and say, hey, there's some things. Maybe Jan borrows some ideas. Or maybe says, here's something where you got it completely wrong. Fix that. Some other ideas, maybe the Bosh agent. One of the things that I don't think Monika brought up, because it wasn't in the slide deck, so she wouldn't have known to bring it up, was the Bosh agent reports its IP back as, well, here's one of the interfaces on the VM, and it's got a heuristic. It selects one, says, hey, director, here I am at this IP. If your director is sitting outside the Kube cluster, that IP is going to be on the overlay network, a private network inside the cluster. So it's going to be meaningless to the director. It'd be a 10 dot something. The director's going to be like, I can't get to that IP. So one of the things we might be usable is maybe you take the Bosh agent and you allow it to have an IP address that you could specify in configuration. So you could give it the IP address of a Kube service, like a load balancer service, for example, or a node port if you want to go, kind of low level, but load balancer is a little more flexible, whereby you'd have an externally reachable address and you expose each VM in quotes, as a service. That's something that would I think be worth doing. The really heavy lifting, though, is at that edge. It's at the boundary, because you got to get over that split brain problem somehow. You know, as we talked about, we had a lot of back and forth on this, and I had some conversations with Jan as well about this. You know, you install this state. We don't think of it as a state, but from a kube perspective, again, remember, it is definitely state. And when kube wants to recreate something, all you get back is what was in the Docker image in the first place, which doesn't include var vcat packages, for example. And there are a number of ways, and Dr. Nick and I chatted about this a little as well. You could, you know, dork with file systems. Maybe you could have some way of, you know, maybe the agent gets tickled when something gets recreated and tells the director, hey, give me your stuff. I mean, there are definitely, and I'll say definitely, there are definitely plausible ways one could solve that problem, but I think they require some investigation, not only the CPI, but even looking into the internals of Bosh. And I don't think I personally am not sure there's a way forward without being willing to do that heavy lifting. And frankly, maybe some of you are sitting there thinking, you've got 4 or 5 other ideas of things we could do. Not sure. And so with that, I think we'll wrap it up and see if there are any questions. It's on all the time, I think.
I feel like if I don't touch the button, I haven't participated. Now it works better. See, the button.
I won't point out that you were just holding the mic close to your mouth.
That's not true. You have any
See?
questions?
Fake news, fake news.
Hey.
I was getting a Trump joke in for your sake.
That's excellent. I asked all my questions the other day, so I'm good. And I'm speaking next, and I was completely not paying attention. That's not true.
You weren't paying attention, were you?
There's a little bit, but I was pretty desperate to get a cool animation that I wanted in my slide deck. Because Chip had something cool, and I wanted it. Because we're an open source community, and we steal each other's stuff all the time.
I have a question. So in the Kubo project, they use Bosh to deploy Kubernetes, and how the approach is different. I mean, what changes?
Well, so that's I would say that's really an orthogonal problem. They're talking about deploying Kubernetes. We're assuming Kubernetes is always there, and we're deploying Cloud Foundry on top of it. So they're really solving 2 different problems. Kubo is a way of, I'm going to use Bosh and deploy Kubernetes. But it doesn't solve the problem of getting Cloud Foundry on top of Kube once it's there. Make sense?
As a thought experiment, you know, parts like the cloud controller and the UAA, they don't need to technically run on Bosh. You could be running them on Cloud Foundry or Kubernetes or whatever, so some of them are easier than others.
So one thing I'm interested in is, I think one path we went down is, here are some features we might want from Kubernetes if it was the CPI, right? And they actually seem like a reasonably small set, potentially, of features, like being able to recreate a machine faster, for example. Have we thought about how we can get those features into Bosh, right? So instead of saying, let's solve this problem by getting the whole of Kubernetes underneath here, maybe these are actually just a small couple of feature requests for Bosh, or is that not something that's practical within Bosh for reasons we can identify?
I don't know whether they're practical or not, honestly, Jules. I mean, it's a good question. At this point, we haven't gone back to Dimitri and said, look, here's the magic we wanted out of Kube. Can we get it out of Bosh too? I mean, some things you obviously can get. You know, the recreation of things Bosh can do. You know, Bosh can recreate missing jobs today. So that's a feature that's there. Now, it might be a little faster in Kube because it's just you know spinning up something new from a Docker image, but it's not night and day faster. But we haven't really, we haven't had the conversation with Dimitri to say, hey, look, here's what we'd like. But at the same token, one might also plausibly argue, well, hey, Kube gives you horizontal scaling, well, so does Bosh. Just change the number of instances, do a Bosh deploy, you got 4 cloud controllers instead of 1. So, no, I don't think the conversation's been had, nor have we really thought about it from that angle, is the honest truth.
Right. What I'm getting at, I guess, is if you want to use Kubernetes as your UX, right, you've developed something for Kubernetes, then I'm in. I understand why you want to do it. But when you start from the position of, we're going to use Bosh and Bosh's UX to deploy this, and Kube's going to be a subsystem that no one's going to see, then I think you have to ask yourself, since no one's going to see it, and I'm going to use Bosh from the outside, is there a faster way of getting there that just does this in Bosh, right?
Yeah.
As long as Bosh is the UX, which sounds like we decided it was what we wanted. I
think we did make that decision. I mean, honestly, I think one of the key problems is, back to that boundary is, containers are not first-class entities in Bosh. I mean, that's you know, and you and I have had this discussion. Jan and I have had this discussion. I mean, I think that's one of the things. I mean, if every problem is, if you only have a hammer, every problem starts to look like a nail, and if everything is a VM, you have to make everything look like a VM. That's one of the problems. I mean, I think if you were going to pursue this in Bosh, you have to figure out a way to make Bosh be aware that there are things in the world other than VMs. That would be the starting point for me. Anyone else?
Thank you very, very much.